We are asked here to graph the function y equals -3 times 2 to the x minus 3 minus 2. And you may be looking at this thinking, wow, that's a lot of transformations. I've got a reflection right here that looks like a vertical reflection, a vertical stretch, and then a horizontal shift, and then a vertical shift right here. So we've got at least 4 transformations to deal with. This is going to take a while. And it's true, it would, if we were doing it with graphing transformations. But there's a quicker way. If you just graph exponential functions using key features, and you do it algebraically. So that's what we're going to do with this exponential growth function. And by the way, the reason I call this a growth function is, see this number right here? That's the base. Okay, remember the base is always raised to an exponent. And in this case, the base is greater than 1. And when the base is greater than 1, that means it is a growth function. That's just what it's called. It's the family of exponentials that are called growth functions. So let's plot this exponential growth function. And here are the steps I'm going to follow. We're going to plot the horizontal asymptote, which is always at y equals k. Okay, there's k right there, that -2. So step 1 is easy. We just say horizontal asymptote, y equals -2. So we come along to this graph here, and let's see if I can do it. I'm going to put this horizontal asymptote right here at y equals -2. Okay, so that's done. Then we need to plot 2 points, and you could plot a lot more points than 2, but I think once we plot 2 points, we kind of get the shape and feel for this curve. So the first point I want to plot is where the exponent equals 0. Okay, so this is going to be xy, where x minus 3 equals 0. So where's that true? Well, that's just at x equals 3. Okay, so now we plug that back into the original equation, and we say y of 3 equals what? Well, it's -3 times 2 to the x minus 3. Remember, that's 0. 2 to the x minus 3 minus 2. And go in steps. This is -3 times, what's 2 to the 0? It's 1 minus 2. And then we have -3 times 1 is just -3 minus 2 equals -5. So the xy coordinate of this point right here is xy equals x equals 3 and y equals -5. So let's draw that on our graph here. 3 is over here and -5 is down here. So I think I'm looking at this point right there. Okay, so we are mostly done. Let's just do one more. And let's see, this one is going to be, what was this? This is where the exponent equals 1. Okay, so x minus 3 equals 1 now. Now, if x minus 3 equals 1, that means x equals 4. And run through putting that into the equation again. What we get is y equals, what's our equation again? Yeah, -3 times 2 to the x minus 3, which is 1, minus 2. Okay, so that becomes -3 times 2 minus 2, which becomes -6 minus 2, which becomes -8. So this xy coordinate is located at 4 in x, -8 in y. So looks like I'm going to need some more tick marks here. There we go. And 4 in x is going to be over here. -8 is going to be down here. So I'm looking at this point like that. Now, let's take a look at what we have. This graph has to hug the exponent, the asymptote, which means I'm going to connect these two dots. I mean, those are easy. Those have to connect like that. And then this function is going to come up close to the horizontal asymptote, but not touch it. Okay, it's just going to hug real close to it. So there's your exponential curve. And the next example, we'll move on to an exponential decay, but I think I'm going to stop the video and start another one.